Chris Chinock here. I'm in the V-Nova booth at IBC 2022. It's had a long talk with the management here, and I'm going to give you a rundown of some of the things they've been talking about. In particular, the first thing that Guido highlighted was the ecosystem that they've been working to expand. So here you see a list of some of the 27, or actually 26 partners, announced partners anyway, that are adopting LCEVC as part of their ecosystem. So quick background, LCEVC, how does it work? It is not a codec, it is a process that can be used with basically any codec. And the idea is you start with the original content. You actually encode a base layer. Let's say if it's a 4K content, you would typically encode that as 1080p, maybe a quarter of the original resolution, and then you add this enhancement layer, which is low complexity. This is how you get the low complexity LCEVC name for this process. Then you create these two layers. You encode them separately. That's distributed, and then at the playback device, the decoder will decode the base layer as normal, and then you need some special software, firmware, to be able to do to add the enhancement layer to improve the picture quality. So they're showing us several benefits here of that process. In particular, this was a demo of a gaming application where, I guess you can see it down here, where they showed this with LCEVC on and with it off, and see a definite increase in clarity and sharpness of the image. Over here is what you see is an M-Logic chipset, and what they're showing here is 1080p content coming into this. This is a typical chipset that's used in set-top boxes, kind of low-end set-top boxes. And so what they're showing is how this a 1080p signal can be that's been encoded with LCEVC can be decoded in this M-Logic standard chipset with some firmware updates and create a 4K image here. They're working with other main chipset suppliers like MediaTek and Realtek and Montage as well. The third area of news that they wanted to focus on is some data that was recently collected by Intel and Meta. So the idea here is to basically prove the value proposition of LCEVC versus with AV1 specifically. So if you look at this chart, this is a BD rate versus encoding time chart. So it's a little hard to figure this all out, but the baseline here is LC is 2.64, so that's AVC, and the dotted line below here is ooh, here we go. Sorry. So the blue here is the X.264, which is AVC, and the dotted blue here is with LCEVC encoded on top of that, at that encoding. And what you can see here is if you go from point to point, you get a BD rate reduction, which means whatever this is, 20 or 40%. So that's a reduction in bit rate, and for the same encoding time, or you can save the processing time to reduce it. And if you get down here, this is now versus SVT AV1, and these various M numbers are presets in AV1, going from the very slow version out here to the much faster versions up here, M11. And again, you can save processing time or increase quality, but you've got lots of trade-offs in it. This is a big deal for them because it proves some of the value proposition that they've been trying to say for the AV1 encoding. third and final piece of news is the release of their SDK and their NDK, the NDK being the native development kit as opposed to the software development kit. And this is allowing customers to do much more intent development efforts, working with particular chipsets and firmware updates and more. So that's pretty much the story from the VNova LCEVC space at IBC. Chris Chinock for the 8K monitor.